part C. If F is 1 pound more than what is necessary to make it move, what's going to happen? Well, it's going to start moving. So I'll just write it up here now. So in part C, F is equal to 1 pound more than that is 3.42 pounds. Right? Now it's going to start moving, and the mu s is going to change to mu k. So this one is going to be here 3.42. And then 3.42 cos, 3.42 sine. Now, the one thing that you have to do with these kinds of problems is if the force that you're pulling with has a vertical component, that changes the normal force. Right? So you have to recalculate the normal force. And then if the normal force changes, the kinetic friction force changes too, because Fk is dependent on N. So now let's first calculate the normal force. N plus 3.42 sine of 35. That's the vertical component. N plus 3.42 sine of 35 is equal to 8 pounds. And from there, you calculate the normal force. So you see, we're recalculating the N. Okay, what do you get? 6.04 pounds. And now, to calculate the acceleration, you take the 3.42 cosine of 35. That minus the mu k, which is 0.2 times n, right? 3.42 cos 35 minus mu k, which is 0.2 times n, which is 6.04. So this is mu kn. So the horizontal component of the force that you're pulling minus the horizontal force that the friction is opposing is equal to the mass of the block, which is 8 pounds is a quarter slug, right? So quarter slug times A. That's how you get the A. If you have any questions, anything, what I did?
How did you get that quarter slug?
Remember, there was 8 pounds. We divide by 32. Is 1/4 slug. The weight that is given, 8 pounds, is the weight. So to get the mass, you divide by 32 pounds is 1 slug. Okay, so what do you get here? A. 6 feet per second squared. So it's going to accelerate at that rate. Okay, and now part D. Part D, the question was what? What is the force you need so that after it moves, it doesn't accelerate? You still pull it, but it goes at a constant velocity. Okay? Now, for that one, what we could do is use the same formula that we had derived in part B. Right? Remember, in part B, it had asked us, what is the force that we need to make it move. And we did that the other day, and we came up with a formula. What was that formula for the force that you need to make it move? Do you remember it? Do you have that from that?
F equals to Fk or UK n.
Well, the other day it was the part B was mu s, right? We used the mu s because we wanted to see how much force is needed to make it move. Now we're going to take the mu s. We're going to use the same equation, but we're going to replace the mu s by mu k. Okay? So wherever you see the mu s, change it to mu k now. So do you have that? And what else? No, part B of the problem, remember? We solved it the other day. Part B, the first thing that we did on Monday, we came up with an equation. How did we get the 2.42? The 2.42, how did we get that? We came up with a certain equation. We came up for a system of two equations. We eliminated that and we solved, we got a certain equation. What I'm asking is, what is that equation?
You want it for the n of
Let me see here.
for the k for the s.
Yeah, okay, so basically we do it the same way, except instead of 0.3, we use 0.2, right? We have F, you know what, look, let's see, we could start here fresh from the start. We could start here fresh from the start. We say, okay, let's say we want to make it move at a constant velocity. We have n plus f sine of 35 is equal to mg. Remember, that's how we started the other day. And we have f cosine of 35 is equal to mu kn. So as long as the f sine 35 plus the n equals mu kn, see, this is f, this is f sine 35, and this is f cosine 35. So what we're arguing is, if this plus this equals to the weight, which in this case is 8 pounds, this is in this case 8, and then if the f cosine 35 equals mu kn, and then we took the n, we substituted into here, and we solve for f, right? So the other day we did this for mu, instead of mu k, we did it for mu s. Okay? So now we do it with mu s. I mean, now we do it with mu k. So we put here mu k is going to be 0.2. N is going to be 8 minus f sine 35. And then you distribute this in. Distribute that in. And then you have f cosine 35. Take this to the other side. Plus 0.2 distributed in, you get 0.2 sine of 35 is equal to 0.2 times 8, 1.6. Okay?